Hi all and welcome to this little sojourn or little wander down the topic of division of polynomials. Now, you see what I did here? Division. Yes, I know, because most people were like, oh, maths is so boring, it doesn't relate to anything. And cell division. Well, okay, look, it's got nothing to do with polynomial division, but I tried. As I say here, by the end of teaching this topic, I would really like the following. 1, you don't have a nervous breakdown. 2, you don't think you can't do this. 3, you don't try and understand the why, just the how. And that's really, really important. Lots of things in life, I don't know why. I just know how. I don't know why my car drives forward. I just know that actually it does. I've got a general idea that there's an engine inside it, but look, I don't really need to understand the why. I just understand that I get in, I turn the key, and off I go. What I really need you to do is practice, practice, and practice some more. And don't give up. Why? This topic alone is actually important and is featured in methods 3 and 4. Now, I'm actually going to throw you 3 things, or I'm actually going to show you 3 things. I'm not going to throw anything at you today. Once I've done that, there are questions here that I would like you to try. Now, that is if you're being taught by me. If you are not and you are watching from internet land, hey, how are you? Good to see you. Thanks very much for taking the time and dropping by. I think it's always important to start with a recap, just so we know where we've been and hopefully where we're going to go. In many cases, we are allowed to use a calculator to find the factors of polynomials, but not all times. Why do we need to find the factors? If you remember, when we're factorizing, we're finding where a graph crosses the x-axis. That's all you're doing when you're factorizing, or at least you're putting it into a form, so long as it's equal to 0, that you can then go on and find these factors or these crossing points. Why do we need these? Well, ultimately, when we sketch graphs, there's certain pieces of information we have to put on. Crossing points on the x and the y-axis are pretty much where all the marks lie. Most of the marks. The great thing is we've been taught how to do this with quadratics. And if you remember, with a quadratic, and this obviously I drew first isn't a quadratic, we can use one of 4, or maybe there are other ways of finding the crossing points, these factors. There was the quadratic formula that x equals minus b plus or minus a square root of b squared minus 4ac all over 2a. There was completing the square method, the t method, and the cross method for those of you out there who understand it. I don't, never will. They are there primarily to put it into a factor form, and then you would solve using the null factor law, as long as it's equal to 0, to then find you these crossing points. Okay? Sadly, these don't really work for cubics or quartics. There aren't a whole range of different ways of doing things for a cubic or a quartic. We have to use other techniques. And one of these is called polynomial division. Now, let's go back to primary long division. And I'm not even sure many people even get taught primary long division anymore. Maybe that's why people find this complicated. But long division stated that if you had 18 into 847, the first thing you did was 18 into 8. Doesn't go. So you do 18 into 84. Right, 18, 36. Ooh, what comes next? 54, and then 60, 72, and then 90, and then why am I doing this? Well, first things first, I need to find out how many 18s go into 84. As far as I'm concerned, there were 4. Now, in long division, you used to write the 4 at the top, and then you would say, well, what were 4 times 18? 72. And taking this little line under here, we would write the 72 down, and we would take it away to help us find the next part of the equation. Now, as it turned out, in this situation, it would have been the remainder. So when I took those away, I would have got 12, and then you were always taught to bring the next thing down. And then I would say, right, how many 18s now are in 127? Well, I could have chosen an easier example to highlight this one, but next one, so add 18 onto that gives me 108, add 18 onto that gives me 126. Pretty sure there's not going to be another one after that. So 1, 2, 3, 4, 5, 6, 7. It goes in 7 times. Again, the minute I write something on there, I used to have to say, well, 7 18s were 126. Take them away, and there was my remainder. Right? So that was taught, and many people were like, I don't understand the process. Well, the process, interestingly, is very, very similar to what you're about to learn, or at least one of the methods. What does it have to do with the price of fish? Nothing, but it does show a process which you're going to employ shortly. Okay, so if we go back to this example here, and I'm just going to write it out again, 847 divided by 18, it gave me the answer of 47. And all the way down here, we had this line and then the number 1. And so, why is this important? First things first, maths is about the language. We have 4 terms here that are really important. The dividend. This inside is called the dividend. It's also the payout you have at the end of the year if you have shares, but shares, anyway, that's another strange use. The divisor. The divisor is this thing here, the thing that's being divided into. Right, so that's called the divisor. The quotient is this bit here. The thing on the top is called the quotient. And hopefully every single one of you, well, there's only one left, will realize that this is called the remainder. Now, later on in methods 3 and 4, we will deal with something called the factor theorem and the remainder theorem, which has absolutely everything to do with that final number here. But we're now going to learn how to do this using algebra. Now, I say buckle up. There are 3 ways to do this. Long division is one of the ways I'm about to show you. This wonderful way called synthetic division, and then division by comparing coefficients. And those of you who watched my previous video will already know about comparing coefficients. So, here we go. Now, long division. I'm going to start hardest and then get simpler. Always good in mathematics, yeah? But the point of it is, this is a process. When I bake a cake, I don't actually care why I'm putting 100 grams of flour in. I don't care that I'm putting 3 eggs in. Someone somewhere who's obviously on a different planet to me and a different pay scale has been taught how to do this. They've sat there and they've weighed it all up and they've tried 16 eggs and 15 works, and they've tried 15 regular eggs and 15 small eggs and it all worked. And I just want to follow the recipe. So in this situation, that's what I'm going to do. First thing we do is we write this out. So x squared plus 7x plus 11, and I'm going to divide it by x minus 2. All right, change your pen color. The first thing to note is you do the first divided by the first. What do I mean by that? This is the first term inside, which I'm going to divide by the first term outside. So, x squared divided by x is just x. I'm going to write this here. Why? Well, think of it as place value. I'm writing my x's above my x's, my x squareds above my x squareds, my numbers above my numbers. You're going to say, but there are no... Chill. There's another example coming up. As soon as I've written something on the top, I am then going to multiply it back. Much like short division, remember, the minute you write something on the top, you multiplied it by the divisor. That's what we're going to do now. So x times x gives me x squared. That's good to see. And now x times minus 2 gives me minus 2x. What was the next thing you did in long division? You took them away. Marvelous. Well, that's what I'm going to do now. X squared minus x squared luckily goes. Now we need to be very careful here. I've got plus 7x minus 2x. Well, a minus and a minus becomes a plus, so that becomes 9x. Yay! Do you remember what the next term was, next process was? Yep, you drag down the next term. So there's plus 11. And you start it again. So what did you do? You would then divide the 9x plus 11 by this x minus 2. But again, always just do the first divided by the first. So my new first term is now 9x. So when I do 9x divided by x, I get plus 9. So there's my plus 9. Second I write something on top, what do? Yep, I multiply it by my divisor. So, plus 9 times x is 9x. Plus 9 times minus 2 is minus 18. Having done that, I take them away. Now, the reason we keep doing this is to actually get rid of these first few terms. If when you do this, you don't get rid of them, you've made a mistake. Again, being careful, I now have plus 11 minus, that minus there, minus 18, which becomes 29. And ladies and gentlemen, I have now completed my long division. Now, how do we write this out? That's something that actually confuses lots of people. What you've got to realize is that what I'm saying is that x squared plus 7x plus 11, so this bit here is now exactly the same as my divisor, x minus 2, multiplied by my quotient, x plus 9, plus some sort of remainder. That actually is one way to write it out. But that's not what the question had asked us to do, and in many cases that's not the answer in the back of the book. What the question asked us to do was actually do x squared plus 7x plus 11 all divided by x minus 2. Well, if I've gone from the term on the left in number 1 to the term on the left in number 2 by dividing by x minus 2, then I'm going to do the same here. X minus 2, x plus 9, plus 29, all on x minus 2, and all on x minus 2. You've got to remember that when you have more than one term, which is something separated by a plus or a minus, you have to divide everything. Well, it's no actual coincidence that that now and that cancel. And so I could have written my answer, and many textbooks will have written the answer as x plus 9 plus 29 on x minus 2. Both answers, as far as I'm concerned, are equally valid depending on what the question wants you. So we've done one example. I'll show you how to do it again with the cubic. Slightly longer example, shows more of the process. Changing pen color, we get x cubed plus 2x squared minus 3x plus 1. And I'm going to divide that by x plus 2. So remember, first divided by the first. X cubed divided by x. So x cubed divided by x gives me x squared. And again, I'm going to write that on my x squared column. The second I write something on the top, I now go back and multiply that by my divisor. Yes, so x squared times x gives me x cubed, which is good. And x squared times plus 2 gives me plus 2x squared. I'm going to take those away. X cubed minus x cubed disappears. 2x squared minus plus 2x squared is minus 2. Oh, interesting. I get a 0 there. Well, doesn't matter. I bring this down. Minus 3x. And I start again. Now, I can't obviously divide 0 by x, but I can divide minus 3x by x. So I'm now going to do minus 3x divided by x. It gives me a negative 3. I'm going to do the minus 3 above there. Now, I have no x term anymore. Don't worry about it. It's fine. It's not a big issue. Second I've written something on the top, I must then go back and multiply it by my divisor. So minus 3 times x is now going to be minus 3x. Gets written under there. And minus 3 times plus 2 is minus 6. Now I'm going to take them away. The problem is that plus 1 is never going to get used unless I actually pull it down on the step ahead of me. So now, ignoring that 0 altogether at the beginning, so we can actually ignore that altogether, I get minus 3x minus minus 3x, which actually is good. They disappear. And then I get plus 1 minus minus 6, which just happens to turn out as plus 7. And that is my remainder. So I now know that x cubed plus 2x squared minus 3x plus 1 can be expressed as x plus 2, x squared minus 3. All right, all I've done is the divisor. This one here is the quotient. And then plus my remainder of 7. Or, if the answer in the back of the book, you would just write x squared minus 3 plus 7 on x plus 2. Why? Because this is my remainder and that's my fraction. Now, it's nothing more than a process. It takes practice. Don't understand why, just understand how. There are definite reasons why we do this, which you will have to have mastered by the time we get to methods 3 and 4. Okay, so that's the first one. The next one is called the synthetic division, and I love this. Now, the good news is that by the time you get to methods 3 and 4, it doesn't actually define which method you use for division, just so long as you can use it. Lots of people like this method. Again, it's a process. How does it work? No idea. Why does it work? No idea. Does it work? Absolutely. So first things first, you look at your dividend, and I write the coefficients. So I've got 1, 7, and 11. Those are the coefficients, 1, 7, and 11. I draw a line or a box, and suddenly someone I spoke to recently called it the box method. Okay, it works for me. And rather than writing minus 2 there, I write plus 2. Again, this is a process. The first number always gets written down, and it's a 1. Whenever I write anything down here, I multiply it by that number there, and I put it here. So 1 times 2 is 2. As soon as I have two numbers in my column, I add them together. So that would become 9. Oh, I've written something here, so it must multiply by the 2. That gives me 18. And then I add them together, and I get 29. And lo and behold, we have finished. Now, those numbers might actually look familiar. 1, 9, and 29. Hold on a moment. 1, 9, and 29. And that's exactly why we read this. Now, a word of warning. This term here was an x squared term. That was x, and that was my constant term. This value, when you've done synthetic division, is always your remainder. So that's the one you're going to write on the end. All other terms count one lower than this. So because that was x squared, this is x, and that becomes my constant. And again, I'll show you more about this when we get to the cubic. But using these bottom lines, I now know that x squared plus 7x plus 11 is the same as, what did we have? We had x minus 2. That's just written from there, multiplied by, reinterpreting this, x plus 9 plus my remainder, which again could be written in a different form depending on what the examiner wanted, right? So that would be x plus 9 plus 29 over x minus 2. Again, it's just a process. Going back and reviewing it and redoing it here, first thing we do is we write out the coefficients. So 1, 2, minus 3, 1. Draw the box. If that's a plus 2, you write minus 2 there. The first value always gets copied down as a 1. Don't know why, don't really care. Bottom value, once I've written something, multiplies by the minus 2, so that becomes minus 2. Once I have something in a column, I add them to get 0. Do you remember we had a 0 before, yeah? Well, this is the same thing. Written something in the bottom, multiply it. 0 times anything is, yes, 0, add. That becomes minus 3. Minus 3 times minus 2 is 6. Add them together gives 7. And once again, do you remember? Our remainder was 7. Now, I've deliberately chosen to do the same questions because we can check that it's actually working. So, we now know that my remainder is plus 7. This was an x cubed, x squared, x and constant. So this now will be an x squared. This will be my x, and this will be my constant. And so I can say that x cubed plus 2x squared minus 3x plus 1 can be re-expressed as x plus 2, x squared minus 3 plus 7. Or if the textbook wants it in a different way. Wow, we've been going for 18 minutes. I'm promising you I'll show you the third method, but it works in exactly the same way as you've done before. Now, we've already done a video on comparing coefficients. How do I now deal with this by comparing coefficients? Right. If I do x squared plus 7x plus 11, and I divide it by x minus 2, I know the first term has got to be an x. It's got to have a linear factor. But I don't know what the rest of it is. So I'm going to say that I can split this up and say that x squared plus 7x plus 11 is equal to x minus 2 multiplied by some linear factor. I don't know what the linear factor is. I'm just going to say ax plus b, which is linear, which is the equation of a straight line. Why? Because again, if I divide a squared term by an x term, I'm going to end up with a linear term. Now, I don't know if there's a remainder, so I'm just going to put plus r on the end of there and hope. Now, if it comes out as 0, then actually there's no remainder, and that's really important in maths. However, going back to what we were doing before on comparing coefficients, x squared plus 7x plus 11 is equal to, multiply these out, ax squared plus bx minus 2ax minus 2b plus r. Collect like terms gives me ax squared plus, take x out of a bracket, we get b minus 2a minus 2b plus r. Well, there's only one x squared term, and there's only one x squared term on that side, so I can automatically put that a must be equal to 1. I know that plus 7x must be equal to plus x b minus 2a. Now, I'll write the pluses for a very specific reason, just so that I don't trick myself if there's a minus. The x there and the x there effectively cancel each other out, so I get 7 is equal to b minus 2a. I know that a is 1, that's right. So I get 7 is equal to b minus 2, or b is equal to 9. And once again, these numbers are sounding familiar. Finally, we know that minus 2b plus r must be equal to my constant, which is plus 11. I know that b is actually 9, so minus 18 plus r must be 11, and so r is equal to 29. And lo and behold, once again, out come my final answer. So putting it back into this format here, I would have x minus 2, a was 1, so x plus 9 plus my remainder of 29. Now I know lots of people prefer that because it's more visual. One more time with the, we'll now do a cubic. So when I do a cubic divided by an x term, I'm going to end up with a quadratic. So I now know that x cubed plus 2x squared minus 3x plus 1 must be written as x plus 2 because that's my divisor. I will end up with a quadratic, and the general form of a quadratic is ax squared plus bx plus c, and we must make sure that we put our remainder on the end. Let's multiply this horrible thing out. We'll get ax cubed plus bx squared plus cx plus, now multiplying everything by 2, 2ax squared plus 2bx plus 2c plus r. Now I'm going to collect like terms. There's only one x cubed term, so that's ax cubed. There'll be 2x squared terms, which is b plus 2a. There'll be 2x terms, which is c plus 2b. And if you remember, this here is my constant. Comparing coefficients, x cubed plus 2x squared minus 3x plus 1. Well, again, there's one x cubed term and one x cubed term, so a must be equal to 1 because that's the coefficient. I know that 2x squared is equal to x squared times b plus 2a. So b plus 2a must be equal to 2. A is equal to 1. So b in this situation must equal 0. And again, do you remember one of those terms disappeared? I should go. Again, go back to my x term. So minus 3x is equal to r. See, there's this minus now. This is where it's important. Plus xc plus 2b. Well, the x's cancel, or yes, cancel out, or divide out. So I get minus 3 is equal to c plus 2b. Well, I know b is 0, so c is equal to minus 3. And 2c plus r must be equal to 1, because that's my constant. Minus 6 plus r is equal to 1, so r equals 7. Three very different ways of doing this. One, synthetic division, I think is really quick and easy, with some caveats. Long division, long, and I think this comparing coefficients is probably longer. Totally down to you the way you're doing it. Please be aware that you can actually use your calculator to do this for you. All you need to do, and I think the expression is the same on both the TI Inspire and the Casio ClassPad, prop frac. Just put prop frac, divide the two together, and lo and behold, there you have your final answer. Now again, just because the calculator is being bizarre, x squared minus 3 would be your quotient. No, it wouldn't. Yes, it would. And plus 7 on x plus 2. That would be your remainder, and that there would be your divisor, which we already know. Okie dokie. Happy? What does this lead to? As I say here, method 3 and 4, and perhaps later in this chapter, you will meet something called the factor theorem and the remainder theorem. They are really, really important areas, but really simple. But before you do those, you have to know how to divide polynomials. And always keep in mind, the whole reason of doing this is to find crossing points on graphs if you can. All right. This was 25 minutes long. Sorry about that, but I think it needed to be. Have a fabulous time, and I look forward to seeing you next time. Hey guys, if you've enjoyed watching this video, why not tune in and subscribe to get updates of when I do other videos. Alternatively, click this video that's coming up now, or just zip on over to MaffsGuru.com, MaffsGuru.com, where you can actually access all the videos in a nice, easy to use way.